All right, here's part 3 where we're talking about quadratics over linears. So I have a nice quadratic in my numerator and a linear on the bottom. Same questions being asked, and I have to sketch the graph once everything's done. So let me look at the asymptotes. There's a vertical asymptote of x equals 1. And if I want to find the slant asymptote, remember I have to do synthetic division. So I'm not going to go through the whole process of synthetic division, but you know you'd have to put 1 on the outside, and then on the inside you would have -1, 4, and -7. And you would do your synthetic division, and for your answer just look at everything except the last number, because that last number is the remainder. If you do it properly, you should get a slant asymptote of y equals -x plus 3. All right. Now let's take the derivative. Again, it's quotient rule, so I took the derivative of the top, -2x plus 4, times the bottom, x minus 1, minus the top, -x squared plus 4x minus 7, times the derivative of the bottom, 1, all over the bottom squared, x minus 1 squared. And I expand everything out, and I simplify everything, and I factor if possible, and I get that the top factors to -x plus 1 times x minus 3. Alright, so that is my derivative. Oops. And what that means is when I set that equal to 0, I've got stationary points at x equals -1 and x equals 3. So using my stationary points and using my vertical asymptotes to split up the domain, this is what I get. Alright, so I've got a stationary point at x equals -1, I've got a stationary point at x equals 3, and I've got a vertical asymptote at x equals 1. So let's look at everything that's going on. Let's try a number that's less than -1, so like -2. -2 plus 1 would be negative. -2 minus 3 would be negative, and the bottom, since it's being squared, will always be positive. So it looks like before I get to x equals -1, I've got a positive first derivative, meaning that the original function is increasing. Let's look at everything between -1 and 1. I will try 0. 0 plus, oh, hold on a second. I just realized something. There's this negative out here too. Okay, there's a negative right there, so a negative times a negative times a negative over a positive is negative, so the original function is decreasing. Glad I caught that. Then between -1 and 1, I'm going to try the number 0. So this negative sign will stay negative. 0 plus 1 is positive, but 0 minus 3 is still negative. Everything's positive on the bottom, so this ends up being positive. The first derivative is positive, meaning that the original function is increasing everywhere between -1 and +1. Now between +1 and 3, I'll try a number like 2. Well, the negative is still negative, 2 plus 1 is still positive, 2 minus 3 is still negative, and the denominator is always positive, so this is still positive, so the original function is increasing. Then after 3, I can try a number like 5. Negative is still negative, 5 plus 1 is still positive, and 5 minus 3 is now positive. Denominator is always positive, so I have a negative first derivative, meaning that the original function is decreasing. Alright, now let's find my intercepts. Same way as before, there's my original function. Something happened here. Alright, there are no x-intercepts because I can't solve the numerator. I can't set the numerator equal to 0 and get a real solution. So, alright, there's some extra stuff in here that needed to go away. And to find my y-intercept, I need to set x equal to 0, and that makes it -7 over -1, which is +7. Alright, so now let's sketch. I have a slant asymptote at y equals -x plus 3. What that means is it has a slope of -1, and it goes through y equals 3. So it's going to kind of go like this. Yeah, that looks pretty accurate. Okay. So there's my slant asymptote of y equals negative x plus 3. All right, everywhere before x equals negative 1, I am decreasing. So let me just draw a little down arrow everywhere before I get to x equals negative 1. There is a local minimum at negative 1 and 6. So 1, 2, 3, 4, 5, 6. That's a minimum. Then I am increasing everywhere between x equals negative 1 and positive 1. So I'm increasing here. And somewhere in there I've got a y-intercept of 0 and 7, which is right here. And there's a vertical asymptote at x equals 1. So let me draw that in. There's my vertical asymptote. Then I am increasing everywhere between x equals 1 and x equals 3. So increasing there. I have a local max at 3 and negative 2. So right there, that's a max. And then I'm decreasing everywhere. Okay, this is not good. All right, I'm decreasing everywhere. This is bad. All of this is bad. Not sure what happened there. All right, but I still have my slant asymptote there. I am decreasing everywhere after x equals 3. All right, so what does my graph look like? Remember, I have no x-intercept, so I shouldn't even think about crossing the x-axis. So let me get close to that slant asymptote, hit that minimum, hit my y-intercept, and come close to that vertical asymptote. Then I am increasing, starting along this asymptote, increasing to that maximum and then decreasing. Alright, so that's what my function looks like. Sorry, I thought I had cleaned this up, but there was some stuff from the previous question. That's what my function looks like. That was kind of an easier one because there was a lot less information. So that is the third example. And if you have any questions, please email me or let me know, and I'll answer them as best as possible. And we will do some more of these tomorrow. This is probably the hardest section in the entire chapter, so please make sure you understand this by asking me questions. I'll be walking around tomorrow anyways to answer your questions.